Good morning, students. In this session, we will be deriving the relation Cp minus Cv is equal to Tv beta square by Kt. So, for deriving this equation, we should be able to write these equations first. That is the first TDS equation. TDS is equal to Cv dt plus T into dou P by dou T at constant volume into dV, and the second TDS equation, TDS is equal to Cp dt minus T into dou V by dou T at constant pressure into dP. So this is the second equation. Apart from these two equations, we should know what is isothermal compressibility and volume expansivity. So isothermal compressibility, it is a term which is used to show or give the variation of volume with respect to pressure at constant temperature. The word isothermal means at constant temperature. So this isothermal compressibility and volume expansivity both are dou V by dou P, that is the change of volume with respect to pressure, and this is also the change of volume only, but with respect to temperature. So isothermal compressibility gives the ratio of change of volume with respect to pressure at constant temperature, and this volume expansivity gives the change of volume with respect to temperature at constant pressure. Before that, we will be having 1 by V. So isothermal compressibility, it is denoted by the term Kt is equal to minus 1 by V dou V by dou P at constant temperature. Here there is a minus sign. Whenever we increase the pressure, what happens is the volume decreases. To account this factor, a negative sign is there. And volume expansivity is denoted by the term beta. This is equal to 1 by V dou V by dou T at constant pressure. This you keep as equation 3 and this as equation 4. Next, this is an important result. Dou P by dou T at constant volume into dou T by dou V at constant pressure into dou V by dou P at constant temperature is equal to minus 1. So this 4 results we should know for deriving this equation, that is Cp minus Cv is equal to Tv beta square by Kt. Take down the two equations, that is equation 1 and 2, the TDS equation. So both are TDS only. We can equate the right hand side of both the equations. So we can equate the right hand side of both the equation. So if we equate, we will be getting Cp dt minus T dou V by dou T at constant pressure into dP is equal to Cv dt plus T into dou P by dou T at constant volume into dV. Now we shall rearrange this equation Cp minus Cv. So this term and this term I am bringing on the left hand side. Cp minus Cv both are having dt as common. So Cp minus Cv dt is equal to T into dou P by dou T at constant volume into dV plus T into dou V by dou T at constant pressure into dP. Now dt is equal to T divided by Cp minus Cv. So you bring this Cp minus Cv on the right hand side, so it will come in the denominator. into dou P by dou T at constant volume into dV plus T divided by Cp minus Cv into dou V by dou T at constant pressure into dP. We know that temperature is a function of pressure and volume, or I can say it is a function of volume and pressure, anything you can write. So from this equation we can write like this: dt is equal to dou T by dou V at constant pressure, dou T by dou P at constant volume. So here I have to write dV. Whatever term is in the denominator, I write here also. Here I am having dou P, so here dP will be coming. Now you compare this equation. You take down this equation as 6 and 7. So this equation you take it as 6 and this equation you take as 7. So comparing equation 6 and 7, we get see both are dt, and on the right hand side I am having dv, here also dv, here dp, here also dp. So before dv, what are the terms? So this term will be definitely equal to this term. Similarly, the term before dp, that is this term shown as a red color dotted lines. So this term will be equal to this term. Okay, so I have to equate both the terms. So T divided by Cp minus Cv into dou P by dou T at constant volume is equal to dou T by dou V at constant pressure. So this equation I will be getting if I equate the terms before dV, and if I equate the terms before dP, I will be getting T divided by Cp minus Cv into dou V by dou T at constant pressure is equal to dou T by dou P at constant volume. So any one of this equation you can take and proceed. So from this equation, so we shall take this equation for copying. So this is the result that has been obtained in the previous page. So with this equation we shall proceed. So any one of these equations you can take, either this one or this one, any one of the equations is enough. So I shall take this equation, the left hand side. So this is T divided by Cp minus Cv into dou P by dou T at constant volume is equal to dou T by dou V at constant pressure. If we rearrange this, we will be getting Cp minus Cv is equal to T into dou P by dou T at constant volume into, so this will be coming on that side, so this will become dou V by dou T at constant pressure. From equation 5, so what is equation 5? This is equation 5. Dou P by dou T at constant volume into dou T by dou V at constant pressure into dou V by dou P at constant temperature is equal to -1. So we have to take this equation 5. So I'm just writing down the same equation here. So equation 5 is dou P by dou T by dou V by dou P. So this at constant volume, and this one at constant pressure, and this one at constant temperature is equal to -1. But in our equation we are having dou P by dou T at constant volume and dou V by dou T at constant pressure. So what I am going to do is I am going to take dou P by dou T at constant volume. So this is equal to minus dou P by dou V at constant temperature. So this will be going here and this will be going here into dou V by dou T at constant pressure. So instead of this term, I am substituting this one. So write down substituting dou P by dou T at constant volume is equal to minus dou P by dou V at constant temperature into dou V by dou T at constant pressure in the above equation. So if we substitute in the above equation, we will be getting Cp minus Cv is equal to T into minus dou P by dou V at constant temperature into dou V by dou T at constant pressure into dou V by dou T at constant pressure. So take the minus out into T. So dou V by dou T, it is present 2 times, so I am writing dou V by dou T at constant pressure the whole square into dou P by dou V at constant temperature. So this is Cp minus Cv. So we have got up to 7 equation. This you take it as 8th equation. Cp minus Cv is equal to minus T dou V by dou T at constant pressure the whole square into dou P by dou V at constant temperature. If you see from this equation, this term dou V by dou T at constant pressure the whole square is always a positive one, because whatever value you get, you are putting a square, so it will be definitely a positive one. And this dou P by dou V for any substance will be a negative one. So negative, here a positive, temperature will always be positive, and here a negative sign is in the formula. So if you multiply all these terms, what you get is plus into plus plus and minus into minus plus. So if you multiply all the signs, you'll be getting the Cp minus Cv value as a positive quantity. So Cp minus Cv is a positive quantity. Cp minus Cv is a positive quantity, or I can say Cp is always greater than Cv. And the second inference is, as t tends to 0, so the right hand side will be totally 0. So what happens is Cp minus Cv will be 0, or I can say Cp is equal to Cv. The same thing will happen when dou V by dou T at constant pressure is equal to 0. So if dou V by dou T at constant pressure is equal to 0, then Cp minus Cv will be equal to 0. That is, Cp is equal to Cv. We know that for an ideal gas, PV is equal to mRT, and V is equal to mRT by P. So I can write dou V by dou T dou V by dou T at constant pressure. So because in the equation we are having dou V by dou T and dou P by dou V, so I am finding dou V by dou T at constant pressure. So dou V by dou T at constant pressure is equal to, I am differentiating V with respect to T. I will be getting m into R divided by P. So what is mR by P? mR by P is equal to, we can say it as V by T also. Similarly, P is equal to mRT by V. If I differentiate dou P, that is P with respect to V at constant temperature, so while differentiating with respect to volume, the numerator term is a constant one. Only the term which has to be differentiated is 1 by V. So mRT, if I differentiate 1 by V, I will be getting minus 1 by V square. So mRT by V square. Now I have to substitute the results in equation 8. So equation 8 is Cp minus Cv. Cp minus Cv is equal to minus T dou V by dou T at constant temperature, the whole square, sorry, constant pressure, this is dou V by dou T at constant pressure, into dou P by dou V at constant temperature. So minus T dou V by dou T at constant pressure is V by T, we are squaring, then dou P by dou V at constant temperature is mRT by minus V square. So v square gets cancelled, and temperature I am having square. So this temperature and this temperature gets cancelled. Remaining I will be having minus into minus is plus and m into r. So Cp minus Cv is equal to m into r. Or I can write like this, Cp by m minus Cv by m is equal to r. So what is Cp by m? Cp by m is the specific heat capacity. So small p minus small v is equal to r. So if you write capital C, it is heat capacity, and if you write small c, it is specific heat capacity. So capital C is equal to m into small c. So we are getting the results as Cp minus Cv is equal to mr, or specific heat capacity at constant pressure minus specific heat capacity at constant volume is equal to r. So this is the final result. Final result in the sense relation between Cp, Cv and r. From this again we have to derive further to get the results as shown here. We know that the equation 8 is given by Cp minus Cv is equal to minus T into dou V by dou T the whole square. So this is at constant pressure into dou P by dou V at constant temperature. This is isothermal compressibility and this is volume expansivity. So up to this we have derived. So from this equation we have to write what is dou P by dou V at constant temperature. So this will become 1 by V into kT, and from this equation I have to write what is dou V by dou T at constant pressure. So this is equal to beta into V. Now I have to substitute this value and this value. So this value has to be substituted here, and this value dou V by dou T at constant pressure is equal to beta V. So this I have to substitute here. So our equation 8 becomes Cp minus Cv is equal to minus T into what is dou V by dou T at constant pressure, it is beta V. So I have to square, since square is there, square into dou P by dou V at constant temperature, it is equal to minus 1 by V into kT, isothermal compressibility. Cp minus Cv is equal to, here a minus sign is there and here a minus sign is there, so minus into minus it will become plus T V square 1 by V into kT. So temperature will remain beta square, here volume square and here volume is there, so I am cancelling, so V by kT. So Cp minus Cv is equal to Tb square V by kT. So dB square V by kT. So the final result as asked in the question has been derived. Thank you.